Hello everyone, I am Dr. Nitin Kumar Saxena. In this video, I'll discuss about the electrical field and electrical field lines. In our previous lecture, I have defined you how the electrical field lines exist for any point charge or any type of charge, any charge have body having the charge, and how the electrical field lines move from positive charge to negative charge. So in this video we will give you the mathematical expression and how can we define the electric field intensity that we will see in this video. So let us begin with our basic knowledge that we have seen in previous lecture, that if we have any point charge or any type of charge or any body and it has some charge, then it will create an electric field around it. So suppose in starting, if I am taking a point charge, so what will happen if we are taking a point charge, then this point charge will create an electric field to around it. Normally electrical field lines are assumed that they are moving from positive to negative. So normally what we consider that all the electric field lines move from positive charge particle to negative charge particle. In many cases we have only the point charge, and since we have point charge, so we can assume that its corresponding opposite charge is placed at infinity. Suppose if I have a positive point charge placed at some point, and then we can assume its corresponding negative charge is placed at infinity, and in this case the electric field lines will start from this point charge and will go up to the infinity. The same can be considered if we have a negatively charged point charge and it is placed at some place. Then we can assume that its corresponding positive charge is placed at infinity, and then electric field lines will come from infinity to this point charge. Okay, so that I have discussed previously also. So let us start with one point charge plus q. Suppose I am saying, okay, suppose a point O, and this O has a charge q. This, due to this q charge, this is a point charge, so what we can assume that its negative charge is placed somewhere at infinity. So if its corresponding negative charge is placed at infinity, what does it mean? It means the electric field lines will start from this point charge in this way in all the direction radially, right? So in all the directions radially it will move towards infinity. This is okay. So what we are assuming? We are assuming for this point charge plus q, which is placed at O, its corresponding negative point charge is placed at infinity. So these lines are moving from this point charge towards the infinity, right? So these are the electric field lines which are moving from this point O in all the directions radially. Is it okay? Now you see, if I am considering any point P which is at a distance of r from this point O, so this means the distance between O and P is r. And now I want to know what is the value of electric field at point P, right? So what we want to know? We want to know that what is the value of sorry, what is the value of electric field at point P? So what is the value of that at this point? The value of the electric field can be given by the formula 1 upon 4 pi epsilon q upon the distance between this r square, right? And if I want the direction of E is also, then I will take E cap, R cap. So this gives, if the point P is placed at a distance R from the point O, and at point O we have charged particle plus Q, from which these electric field lines are generated, and at a distance R we have a point P. At this point P, what would be the value of electric field? So the value of electric field can be given, in this, by this formula. So what is the value of, what is E? E is called electric field intensity. Okay. So what we call to this E is called electric field intensity, means the magnitude of electric field at particular point P is given by this formula. Right. Now suppose at point P we have a small charged particle, small plus Q. Right. So what will happen if I am taking, this is also plus, this is also plus, so both the charged particles are of positive nature. So what will happen? This plus Q will experience a repulsion force due to this plus Q charged particle. Okay, so we can say that here we will get a repulsion force F, right? So what will be the value of F? This can be found out by using the Coulomb's law. This can be calculated by using the Coulomb's law. And what Coulomb law is? 1 upon 4 pi epsilon Q upon R square, and of course since this is a vector, so R cap. Right? So we have two formula, one for electrical field intensity, one for the force. If I compare both the formula, what I will get, or if I compare, so I will get F equals to Q. Right? So what I will get? I will get F equals to QE. Means the force on this small q charged particle can be calculated by multiplying the magnitude of this charge with the magnitude of the electric field intensity. Right? Again, if I want to write the value of E, so what is the value of E? E is F upon Q. So in this way, I can define the value of I can define this electric field intensity. What is the electric field intensity? If I put Q equals to 1, then E equals to F. And hence, for any unity charge particle, the force experienced by a unit charge particle is called electric field intensity. So what I can say? I can say the magnitude of force experienced by unit charge due to source charge is called electric field intensity. Okay, so how can we define the electric field intensity? Electric field intensity can be defined as the magnitude of force experienced by unit charge. Okay, unit charge. Or I can define again by putting the word test charge. Unit test charge due to the source charge is called electric field intensity. Since this electric field lines are due to this plus Q, So this plus q is normally called source charge, right? And this plus q is experiencing a force, or it is used to test the value of electric field in space. So this is called test charge. Okay, so if I am putting the value of test charge 1, then the force experienced by this test charge in the electric field, which is produced by this source charge q, is defined as the electric field intensity. Is it clear? So in this way we can define what is electric field intensity. Now if if you see here I'll rub it and then I'll see. Okay, what I am saying, suppose electric field lines are moving. Suppose electric field lines are moving like this. Okay, this is the direction of electric field lines, and in this electric field lines, what we have any test charge particle plus q, right? So these electric field lines are coming from this place to this place, or we can say from positive to negative. So due to this electric field lines, this plus q charge particle will experience a force in this direction, right? While if we have minus q charge particle, then what will happen? For this minus q charge particle, if we have this source charge over here, so this source charge will attract, so it will experience a force in this direction, right? So what does it mean? It means if we have an electric field, okay, suppose we have electric field which is going like this, right? So if we have a positive charge particle which is placed in this electric field, so this positive charge particle will experience a force in the direction of the electric field. While if we have a negative charge particle, then it will experience the force opposite to the direction of this electric field. Is it clear? I'm again repeating here what I am saying. I am saying, suppose, if I have, okay, I am using the same figure. If I have plus q charge over there, right? So electric field lines are moving like this. And if I have any charge particle, test charge particle plus q is placed at this point. Okay. So what will happen? This plus q will repel to this plus q. And since it will repel to this, so what would be the force direction? This. And in the same way, if I have minus q over here, so what O will do, plus q will do, it will attract. So direction of the force will be this. So you see, on plus q, we have the force in the direction of electric field, while on minus q, we have the force in opposite direction of the electric field. Okay. So what we can conclude? We can conclude that a positive charge placed in electric field experiences a force in the direction of electric field, right? While a negative charged particle or charge placed in electric field experiences a force in opposite direction of electric field. This is okay. So I hope this point is clear to you, that if we are placing a positive charge in the electric field, then it will experience a force in the same direction of electric field. Otherwise, if it is a negative charge, then it will experience a force in the opposite direction of the electric field. Right? Is it okay? Now you see, the next point is suppose I have a plus q charge particle, point charge particle. Okay, so what will happen? I told you that for this positive point charge, it will give, for this positive point charge, what will happen? It will give the electric fields radially in all directions. So if point charge, I am supposing, imagine a three-dimensional figure. So in three-dimensional, if I am putting a point charge over here, so it will give the lines in all the directions, right, in 3D. So suppose if it is giving the electric field lines in all the directions, so if I draw a sphere over here, okay, if I draw a sphere over there, supposing the point charge is at the centroid, and from this centroid I am supposing a sphere, and for this sphere the electric field lines are moving. So since this distance is constant everywhere, so what is the value of E is 1 upon 4 pi epsilon Q upon R square. So at the surface of this sphere, at every point, I will get the equal value of the electric field, right? Because we are from the center at the same distance. Wherever we are moving on the surface of the sphere, we are at the same distance. So this means the surface of the sphere, if I am supposing like this, so the surface of the sphere, each and every point has the same value of electric field, right? And this is called spherical symmetry. Okay, this is called, we have the symmetry of the sphere on the sphere, so it is called spherical symmetry. And we can say, yes, if we have a point charge, so point charge has a spherical symmetry, right? The point charge has a spherical symmetry. In the same way, if we have a part charge which is like this, like if I am saying, if I have a line charge, okay, if I have a line charge, So for this line charge, suppose charge is uniformly distributed on this line. So if I draw a cylinder like this, you imagine a cylinder like this, and this line is at the center of this cylinder. So you will get all the points are at the equal distance, and since all the points are at the equal distance, I am neglecting the behavior at the ends. Okay, I am neglecting the what I am assuming, this line charge is infinitely long, so there will be no end. Okay, there will be no end. So this cylindrical surface will have the equal value of electric field intensity at every point. And what I will say in this case, I'll say that if we have infinite long line charge, then it has a cylindrical symmetry. Okay, so if we have infinitely long line charge, then it has cylindrical symmetry. Now let us do the two conceptual questions for a better understanding of this electric field. The question is, first I'll draw the question, then we will try to give its answer. Okay, so what is the question? The question is like, I have two plates, right? I have two plates. Okay, plate. This look like a line, but it is a plate, right? Because I cannot draw in 3D. So, if I want to draw, then I will draw like this. Okay, so like this. So we have two plates, right? And the plates are such that this plate, okay, let me allow the same thing I am drawing again with a single line. And suppose this is negatively charged and this is positively charged. Okay, so what we have? We have two plates. Number one, first is negative plate, the second one is positive plate, and a charge particle, suppose plus q is somewhere near to, okay, plus let me allow to do it in a way that we have again I am repeating, we have two charged plates. This is negatively charged, this is positively charged, and I have a negatively charged particle near to this plate. Okay, suppose minus q, right? Or we can say electron. If we are talking about electron, suppose this is an electron. So electron is near to this plate. So obviously electron is a negatively charged particle, minus q type, right? So you see, if electron is here, and so the question is that how much time this electron will take to come from this plate to this plate. Say this is plate A and this plate B. So how much time this electron will take to come from this plate to this plate? Initially it is at rest, right? So how much time this electron will take to reach at plate B or surface B from A, assuming initially electron is in rest. Okay, So assuming initially electron is in rest. Suppose this is positive plate, this is negative plate. So we know that electric field lines will be like this, right? And if electric field lines will be like this everywhere, okay? And this electron is negatively charged. So I told you that the force is experienced in the opposite direction of the electric field lines. So this electron will experience a force in this direction, right? If I am saying the electric field value is E between the plate A and B, right? So what would be the value on electron force? So force on electron will be F equals to QE. So Q is E, so EE. Okay, this will be the value of force on this electron, right? If mass of electron is ME, the mass of electron is ME, and we are neglecting the gravitational force for this problem. We are not considering the value of gravitational force. So what will be the, according to Newton law, F equals to ma. So what will be the value of acceleration? F upon me. This is E upon me, right? So this is the acceleration which is experienced by electron from when it will come from plate A to B. Now you see the equation of linear motion, S equals to ut plus half at square. If I am saying the distance between the plate A and B is d, so this S is d. Given that the initially electron is in rest, what does it mean? This means the value of u is 0 plus half A is given. What is the value of A? The value of A is E upon me t square, right? So when we find t, so this will be 2met divided by E, the square root of this. Okay, so this will be the answer. So the electron will take so much time to reach from the plate A to plate B. If the distance between this plate A and B is d, the value of electric field is E, and the initial electron is at rest. Is it clear? The same exercise can be done with proton. If I change the problem like if I am changing the problem like that, this is positive plate, this is negative plate, distance between these two plates is d, the value of uniform electric field is E, so electric field lines will go like this, and if we have a proton over there at the near to the plate, the first plate, positive plate, sorry, so how much time it will take? Naturally, if it is a positive, then it will experience a force in the direction of electric field. So what will be the value of F? F will be the electron, the charge on proton is also E, so E, again what is A? E upon MP, so again S equals to ut plus half at square. Substitute d equals to 0 into t plus half E upon MP into t square. So t will be under root 2 mpd divided by E. Right? So in this way we can find how much time it will take to reach at plate B, right? So in this way we have studied that what would be the effects of a single point charge if we are trying to find the magnitude of electric field at particular point. Same study can be repeated if we have multiple charges and we want to know what would be the value of the overall electric field at a particular point. Let's see this in way. Suppose I am saying I have plus Q1, Q2, Q3 and suppose minus Q4. So these are the four sources. So the source charges are Q1, Q2, Q3, Q4. Suppose this point is A, this is B, this is C, and this is D, and this is point O. So the question is find the value of electric field at point O due to the four source charges A, B, C, and D. So the question is find the resultant electric field intensity at point O due to four source charges plus Q1 plus Q2 plus Q3 and minus Q4 placed at point A, B, C and D respectively. Okay, so the question is find the resultant electric field intensity at point O due to four source charges Q1, Q2, Q3 and minus Q4 which are placed at point A, B, C and D. So the same procedure we will follow that we have followed for getting the force due to will work over there also. So how can we find? So you see at this point O, suppose I'm at this point O, we have to find the value of electric field intensity. So electric field intensity at O will be the electric field intensity at O due to A, due to B, due to C and due to D, right? It's okay. So you see 1 upon 4 pi epsilon Q1, this is Q1 upon R O 1 square, R O 1 square means the distance between the point O and this, or you can say R O A square plus 1 upon 4 pi epsilon Q2 upon R O B square, distance between the point O and B, and of course since this is a vector quantity, so what I will write here, R O A cap, here R O B cap, plus 1 upon 4 pi epsilon Q3 upon ROC square ROC cap, and finally for this negative charge 1 upon 4 pi epsilon minus Q4 upon ROD square ROD cap. Right? This is okay. So like if I want to draw the lines, so how can I draw the lines? I can draw the lines like see, this will give electric field in this direction. So this will be EOA. This will give in this direction. So EOB. Okay. And this C will give in this direction. So EOC. And since D is a negative charge, so I told you that the negative charge direction electric field will be opposite to this. So what we can say, the direction will be this EOD, right? Because normally we suppose a point charge is positive. Sorry, this test charge is positive. So these will be the direction of all the electric fields, and if we know the exact location of this point, so we can find the angle from, suppose we are drawing this reference line, and from reference line we will get these angles, and once we will get the angles, so according to the method which we have already used for the force, we can find the value over here also. Is it clear? So this is how can we find the value of electric field if we have number of charges placed in this space, and we have to find the value of electric field intensity at a particular point. Is it clear?